Today we're going to be learning about graphing quadratics in intercept form. By the end of this video, you'll be able to graph a quadratic in intercept form and be able to write the equation in intercept form of a quadratic when given the graph. So let's think about this for a minute. If you have a quadratic with x-intercepts of 2, 0 and 4, 0, where would the axis of symmetry be? So we can use this graph to help us figure that out. So that's the point 2, 0, and that's 4, 0. Since quadratics are symmetrical, we know that the axis of symmetry will cut the graph in half, which means it will be right between these two x-intercepts. So our axis of symmetry will be x equals 3. So if A is 1, what would the vertex of this parabola be? So if A is 1, we know that that means from the vertex you go over 1 and up 1 to get your first points, which would mean that our vertex is right there at 3, -1. So we're going to use these ideas to help us graph quadratics in intercept form. So here is the general form of an equation in intercept form. A is the same as it's always been. It's going to stretch or flip the graph. And then you have x minus p and x minus q in parentheses. So the first step, since this is called intercept form, the first thing you do is find the x-intercepts. And your x-intercepts will be the points p0 and q0. The next thing you need to do is find the axis of symmetry. And as we just saw in the previous example, the axis of symmetry is going to be the middle between the two x-intercepts. So you can either just figure that out on your own, or if you like formulas better, you can do the formula p plus q divided by 2, or it's the middle of the x-intercepts. The third step is to find the vertex. Now, just like with standard form, the axis of symmetry is going to be the x-coordinate of the vertex, and you need to plug that number in for x to find the y. So it's going to be axis of symmetry, and then you plug the axis of symmetry in for x to get the y-coordinate. The fourth thing is to find the y-intercept. And as we mentioned in our previous graphing tutorials, whenever you want to find the y-intercept, you just plug 0 in for x. And last but not least, we're going to use the quadratic pattern, which is the over 1 up 1, over 2 up 4, over 3 up 9, and A to help us graph the rest of the points. So let's take a look at a couple of examples. So our first example is y equals x minus 3 times x minus 7. So our roots, remember that roots are another word for x-intercepts or zeros or solutions, are going to be p and q, which are 3, 0, and 7, 0. So we can go ahead and graph that. Then our axis of symmetry is going to be the middle between those 2 points, which the middle between 3 and 7 is going to be 5. So we can go ahead and graph that. Then our vertex. We know that our vertex is going to be 5 and then whatever the y value is. So you can either do this in your head. If you plug 5 in for x, you get 5 minus 3 times 5 minus 7. So you get 2 times negative 2, which is negative 4. So you can do that. Or you can use the store button on your calculator. So just a reminder of how to do that. Our axis of symmetry is 5, so we're going to store 5 for x. And then we type in our equation, x minus 3 times x minus 7. And we end up with negative 4. Either way is fine. Then we can go ahead and graph our vertex. Now our y-intercept, we need to plug 0 in for x. So again, you can either do it in your head or you can use the store button. So if we type 0, store for x, and then copy that equation down, we end up with 21, which means our y-intercept is 0, 21, which I can't draw on my graph. So before we do domain, range, and end behavior, let's go ahead and finish graphing. So since a is 1, we know that from the vertex, we're going to go over 1 and up 1. And then we've already got over 2 and up 4. Our next one would be over 3 and up 9, which I can fit on the left side of my parabola, but not on the right side. So then I can go ahead and connect. And there I have my parabola. So the domain of every quadratic, hopefully you remember, is negative infinity to infinity, or all real numbers. The range, if we look at the graph, the lowest that the graph goes is negative 4. The highest that it goes is infinity. And then our end behavior, remember, is always as x approaches negative infinity, f of x approaches, and then we'll fill in the blank in a second. And as x approaches positive infinity, f of x approaches blank. So if we look at both ends of this quadratic, both arrows are pointing up, so both of these will be positive infinity. Let's look at another example. So we have the equation y equals negative 2 times x plus 2 times x plus 4. So since in our original equation we had x minus p and x minus q, we're going to have to change the signs to get our zeros or our roots or our x-intercepts or solutions, just like we did in vertex form with h. So our zeros are going to be negative 2, 0 and negative 4, 0. So I can go ahead and graph those. Then our axis of symmetry is going to be in the middle, which will be x equals negative 3. Then our vertex, so we know that our axis of symmetry is negative 3. So I can either plug that in and do the math in my head or use the store button. And either way, let me just remind you that you need to type the whole equation in. So our whole equation is -2 times x plus 2 times x plus 4. So you need to remember to put the -2. And you get 2. So our vertex is -3, 2. So here's a good spot to stop and check and make sure your graph makes sense. If you look here, I have 3 points. I have the two x-intercepts and the vertex, and it looks like my quadratic is going to be upside down. So, based on what we know about A, I know that A is -2, and when A is negative, it should be upside down. So it's a good point to just stop and make sure that your graph makes sense. So when we do our y-intercept, remember that we need to plug in 0 for x. So you can either do that in your head or use the store button. But either way, you should get -16. Which again, I can't plot because my graph is not big enough. So then I'll fill in the rest of the points before I figure out the domain and range. So since A is -2, I know from the vertex I need to go over 1 and down 2, which I have. Then usually you go over 2 and down 4, but I need to double that and make it down 8. So I can go ahead and sketch my parabola. Then my domain should be easy. It should always -infinity to infinity. The range, the lowest that it goes is -infinity. The highest that it goes is 2. Then my end behavior always starts out the same way. As x approaches -infinity, f of x approaches blank. And as x approaches positive infinity, f of x approaches blank. So if we look here, both arrows are pointing down, so both of these will go toward -infinity. Now, we can also write the equation from the graph. We just need to know 3 things. We need to know A, and we need to know both of the x-intercepts. So let me write down, remember that our equation will be A times x minus p times x minus q. So I need to find A, P, and Q. So A is going to be the same thing that we've done for the last several days. Start at the vertex, you go over 1, and then you look and see how far you have to go up or down to get to the graph. I have to go down 1, so A is going to be -1. My two x-intercepts are -2 and -4. So P is going to be -2 and Q is going to be -4. So if I write this in my equation, I have y equals -1, or you could just write a negative, x minus -2, which is x plus 2, and x minus -4, which is x plus 4. So that's my equation for the first graph. Now if I look at the second graph, I start at the vertex, and then go to the right one, and see how far up or down I go to get to the graph. And I have to go up 1/2. So A is 1/2. Then if I look at my two x-intercepts, P and Q, one of my x-intercepts is -1, the other one is 5. So when I write out my equation, I get y equals A times x minus P, so x minus -1 is x plus 1, and then x minus 5.